Hello everyone, I am CHANLINGYI and she's TANHUEIQING, and we are from the Bachelor of Information Technology in Software System Development, RSD SEM 3 Group 2, who currently enroll in the BAIT2004 Fundamentals of Computer Networks. We are excited to present this assignment for the course. This assignment revolves around the scenario presented by Sri Muda Gold SDM BHD, a new food processing manufacturing plant in Johor, Malaysia. As the land engineers assigned by Sri Muda Gold SDM BHD, our task is to design and implement local area networks for the company, ensuring efficient connectivity and meeting the requirements outlined in the scenario. Throughout this assignment, we will delve into various aspects of network design, configuration, and testing, aiming to create a robust network infrastructure that supports the organization's operation needs. Let's delve into the details of this assignment and explore how we can create an optimal network solution for Sri Muda Gold Sdn Berhad. These slides show how we calculate the number of hosts needed, included the 20% of future growth for each department. Here will be the total number of hosts needed for each department. We are using Class C private address as that accommodate the required number of hosts for each subnet while still providing efficient utilization of IP address. The largest department, which is manufacturing, requires for 240 hosts, while Class C address can support up to 254 hosts per subnet. The advantages of using Class C address is we can simplify the addressing scheme, network management, allows for easier configuration and troubleshooting as the company is still new. We are aiming to reduce the wasting IP address and no requiring overly large subnets. Since the size and requirement of each department and production line is given, we have decided to use the VLSM scheme for this scenario. This is because VLSM allows for more flexibility by dividing the network into varying sizes, and it provides efficient use of IP address based on the requirements. In this case, we also can minimize the wastage caused by this slide show how we design the network. Firstly, we will identify the largest subnet requirement, which is manufacturing. Then we will allocate IP address ranges from the largest to the smallest. Determine the subnet mask. And here will be the rows, which is the last address will be the default gateway for each subnet. The first usable address will be the router interface connected to the switch address. The second usable address will be the switch IP address. The third usable and the middle with the last usable address will be the 3 end devices IP address representing all of the hosts. Here will be the VLSM table, and we have staked out all of the subnets, number of hosts needed, including the 20% of growth, host bits, subnet mask, network address, and usable host address range with the broadcast address. Here you can see we are calculating from the largest subnet until the smallest. Next will be our addressing table for our router. Our router is renamed as router RA, RB, RC, and RD based on the building name. So the RA is for router building A. We have specified the interface, its IP address, and the subnet address for each router interface. Next will be the addressing table for all switches. Aims to go with the end devices. This is the addressing table for end devices in building A. Building B and C, building D. Here will be our summary based on building, and here will be the number of hosts it needed. Host, we will use 3 end device to represent all of the hosts, and host range, which is the usable address and the default gateway. Next will be the network topology, and I will pass to Hui King to continue with you all.
Okay, so let's see our network topology. Our network topology have 4 routers in each of the building, which is building A, building B, building C, and building D. So for building A, we have 6 departments. Building B, the ground floor have NDP and quality department, and the first floor is ER and D. For building C, we have 3 production line, which is production line 3, 4, and 5 in the same floor. And the last one, building D, have 2 production line on the ground floor, which is production line 1 and 2. Network topology, we have 4 router in each of the building and 15 switch in each of the department and 3 end device in each department as well, which is 1 PC, 1 server, and 1 printer. For the connection of router to router, we have used a fiber optic cable for connecting router from building A to router building C and router building B to router building D. Because of the distance are over exceed 100 meters, that the distance can be supported by a copper crossover cable. And then the connection of router building A to router building B and D, we use the copper crossover cable because of the distance are under 100 meters. And then for the connection of router to switch and switch to end device, we use the copper strip tube to connect. And now for the network configuration, we have 4 router. This is one of the example of router 1 to configuring password. We set the router host name based on the building. For example, router 1 that located on building A, so we will set the host name as R8. So the password for every router, we set the same one, which is Cisco 2024, and the secret password will be the class 2024. All the password is encrypted, and we also set the banner, which is authorizes access only. And the last copyright start is to save. Okay, next for configuration, the IP, we enter the secret password and the password of console line. We enter all the interface with the IP address and subnet mask and set it no shutdown. And the last copy run start to save all the setup. So for the switch is the same with the router 1. For switch 1 to 15, we assign the VLAN IP address and the default gateway for the switch as well. And the switch IP address will be the end device default gateway. Here are the example of the end device, which is PC 0, server 0, and printer 0, the IP address, subnet mask, and the default gateway. And the ping connectivity is to make sure each of the department that can ping to every department in different building. So we have configured the IP static route in each router. Okay, now I will trying to ping from one PC to the same building but different department, and for the different building and different department. So I will use the PC 0 from building A management department to finance department, the PC 2. So ping 192.168.8.131. Try again. So we will get the result that is successful ping and 0% loss. And the second one, I will try to ping the building B, quality department, the server. So ping 192.168.5.61. So here we can get the result that is successfully ping and 0% loss.